Uniform motion problems. So the formula for uniform motion problems is that distance equals rate times time. So usually we write it as d equals rt. Okay? So that's been a formula around forever. So if you're traveling at 60 miles an hour and you drive for 5 hours, you're going to go 300 miles. That's the idea, okay? Rate is the same thing as speed. I noticed in the problems a lot of times they use the word speed. That's the same thing as rate. Distance is how far you're traveling, so many miles, so many feet. Time is, it could be in hours, could be miles per hour, it could be feet per second. They do that in science classes. For our problems, I think we're talking more like traveling by train or plane or something like that. Okay, so in example 5, an express train and a local train leave Pittsburgh to travel to Washington, D.C. Now we could draw a little picture. Here's Pittsburgh, and they're going to Washington, D.C. The express train can make the trip in 4 hours. So it takes them 4 hours. That would be the time that it takes for the express train. The local train takes 5 hours. And the speed of the express train is 12 miles an hour faster than the speed of the local train. Okay, I'm going to set up a chart here because a lot of times we do that with these types of problems and some other problems as well. Okay, so up here I'm going to put the rate, the time, and the distance. And I have 2 different trains. I have an express train, and I have a local train. And we already know the time. We know that they're going 4 hours for the express and 5 hours for the local train. Now this next part's important. It says the speed of the express train is 12 miles an hour faster than the speed of the local train. So let's say I used L for local. That's the speed then of the local train. The express train is 12 hours faster, so L plus 12. Now, hopefully that makes sense. Distance. We don't know how far it is from Pittsburgh to Washington, D.C., and we're not going to look it up, okay? So we just know that it's some distance. But we know it's the same distance, right? Between Pittsburgh and Washington, D.C., it's the same distance. So if in the express train, it takes L plus 12 times 4 to go D, to go that distance. And the local train, it takes L times 5 to go that same distance. Well, the 2 distances have to be equal. So L plus 12 times 4 has to equal L times 5. Now, I don't like the L times 5, but I just did that because of the way our chart was. I can distribute on the left, so I get 4L plus 48. And over here, I'm going to switch it because multiplication is commutative, so I can make that 5L. All right, so I can subtract 4L from both sides. I just used L for local. You might want to use X or something. 48 equals L. What was L? L was the rate, or how fast the local train's going. So the local train is going 48 miles per hour. Now, how do we know it's miles per hour? Because they gave us the units right here. It said miles per hour, so we were going to find the rate in terms of miles per hour. And the express train is going 12 miles an hour faster, or 60 miles per hour. How do you get 60? Well, it's the 48 plus 12. Okay? All right, that's the answer.